We discuss the basic terminology of number properties. In this video and the next consequent videos, I'll be just discussing about a few concepts in isolation, which are like micro concepts. We need to know them in order to answer the other questions very effectively. So here, before I start teaching you this concept, I just want to give you an exercise so that you can try it out on your own, and then we will discuss how to answer such a question. So here, a very basic question for you is, can you just find out how many factors does number 100 have? Now, the options given to you are in the beginning 6, 7, 8, 9 and 10. If you really want to maximize the effectiveness of the video, I would really encourage you to just pause this video here, try this question on your own, and then come and check the solution of this question. However, I'm just going on and explaining the solution here. So the question basically looks for how many factors does the number 100 have. So the very first thing that I want to explain to some of the people who are just starting off is that the factors of any number are those numbers which can divide the principal number completely. For example, if we start looking at the factors of 6, then the factors of 6 will be 1, 2, 3 and 6, because when 6 is divided by either of these four numbers, then the remainder is 0 and 6 is completely divisible. So the factor is a number which can divide the principal number completely without leaving any remainder. So here the question is, how many factors does the number 100 have? There are two approaches to answer this question. In fact, three. One is the unstructured approach, that we start writing down all the factors one by one, right? For example, we can do that, like first factor is 1, then 2, then 4, 5. The next is 10, 20, 25, 50 and 100. And then we can count it. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is the answer. That's absolutely fine as long as we have a pretty decent command over the factors and we are not missing out on any one of them. However, what I recommend is that we make it slightly more organized. An organized way of answering this question will be that we start writing the number as a product of two integers. As a product of two integers means we start writing it like 1 into 100. In that case, what's happening is that we are just thinking of 1 and 100 is coming out automatically. Similarly, the next factor that I'm thinking of is 2 and 50 comes automatically. Next factor that I think of is 4, 25 comes automatically. 5 I think, 20 comes automatically. 10 I think, and other 10 comes automatically. If you carefully look at all the factors, then you will see that we are pairing them up in this way. The smallest factor multiplied by the biggest factor, the second smallest multiplied by the second biggest, and that way. So that is how we see that two factors in each step, except in the last step where we have only one factor, so the total we have 9 factors. Rather than writing all the factors one after other, I find this is slightly more effective way. Also, it takes slightly less efforts as well, because all we have to do is think of these smaller factors and the bigger factors automatically get derived. So that is slightly effective method. Now I am taking you to another thing and then make it more mathematical. Now, to calculate the number of factors, another thing that we can do is we can do the prime factorization. The prime factorization is one step that is repeated many times whenever we get a number that is big or substantially big, because every property of the number is hidden in the prime factors that it consists of. Therefore, we start breaking down any number into its prime factors. The process of breaking down the number into the prime factors is quite simple. You think of the first breakup of the number and then you start breaking it down further. For example, 100, the first thing which anyone can think is 2 times 50. 50 can further be broken down as 2 times 25. 25 can further be written as 5 into 5, which is 5 squared. However, I prefer to break it down in this way, 4 into 25. That means from the first step, I start segregating the like prime factors distinctively. So the bottom line is, the first step that we do is prime factorization of number. That means 100 can be written down as 2 square times 5 square. Now realize one very important thing. Will 2 raised to the power 0 be the factor of this number? The answer is yes, because anything to the power 0 is 1 and 1 is factor of every number. The next question is 2 raised to the power 1 the factor of 100? The answer is yes. Is 2 raised to the power 2 the factor of 100? Yes, 100 is divisible by 2 raised to the power 2. Is 2 raised to the power 3 a factor of 100? The answer is no, because 100 is 2 square times 5 square, which is not divisible by 2 raised to the power 3, because eventually we are left with 2 in the denominator. So no, 2 cube is not the factor of 100. Similarly, we start figuring out that 5 to the power 0, 5 to the power 1, 5 to the power 2 are factors of 100, and any higher power of 5 will not be a factor of 100. Another thing is that if you take multiplication of any two numbers, one from the first column and one from the second column, it will also be the factor of the same number. Such as you take any multiplication of these numbers and that will be the factor of this number. So the total possible combination that we are coming up is 3 into 3, that is 9. If you did not understand the combination, let me write them down. The first combination is 2 raised to the power 0 times 5 to the power 0. The second combination is 2 raised to the power 0 times 5 to the power 1, 2 raised to the power 0 times 5 raised to the power 2. Then 2 raised to the power 1 times 5 to the power 0, 2 raised to the power 1 times 5 to the power 1, and 2 raised to the power 1 times 5 to the power 2. That way we have written all the 9 combinations, and the number of factors of 100 is 9. Alright, having done this, I don't want to formulate it right now because I want to perform another example of such a type, and then I'll summarize it all. So what I'm doing here is I'm just clearing off the board, and then I'll quickly start with another question. Alright, okay, so please note it down. I'm erasing it. So this is done, this is out. I'm changing the number from 100 to 72 now. And the options now that you have will be 9, 10, 11, 12, 14. Think about it. Once again, you can pause it, you can try all possible ways and then find out the answer. I'm going on anyway. 72. When we start writing the number as a product of two numbers, we can write it this way: 1 times 72, 2 times 36, 3 times 24, 4 times 18, 6 times 12, 8 times 9. And then they start repeating 9 times 8 and so on. So I'm not writing them further. Total combinations we have is 5, 6, and every combination has 2 factors. So in total that we have is 12 factors. Right? Let us quickly verify it. 72 when prime factorized can be written in the form of 2 cubes times 3 square, which means 2 raised to the power 0, 1, 2, 3 will be the factors of this number. 3 raised to the power 0, 1, 2 will also be the factor of this number. That means the total number of factors that we have will be 4 times 3, that is equal to 12. So verified. Now that we have learned this method, now I'm going to formulate it. In order to formulate it, we need to understand that the first thing we need to do is prime factorize the number, which means if we have a number n, then we start writing it down in the form of a to the power p multiplied by b to the power q multiplied by c to the power and so on, where a, b, c, etc. are distinct prime numbers. I'm writing distinct because I don't want anybody to write this 72 as 2 times 3 square times 2 square. That will be a wrong way, because we cannot repeat one prime factor twice in the prime factorization like this. All the powers should be clubbed at one place. So we write it this way, and then the number of factors can be calculated. Look at it carefully. When the power was 3, we got here 4, and the power is 2, we got here 3. The reason is we are starting to count from the power 0. Similarly, in 100, it was 2 square times 5 square, and the thing we got was 3 into 3, that is 9 factors. That is once again because we were getting always one more than the power in the last step. So what we have to do is we have to just add 1 in the powers and multiply them to find out the number of factors. So this is how we can summarize finding out the number of factors of any number, howsoever big that is. I'll stop here. In the next exercise, in the next video, I'll be taking a few examples and really good examples around the same concept. Thank you so much for watching this video.